Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is my solution to the homework assignment for the lesson number 20 given by Paul McWhorter with a course called Raspberry Pi Pico W. Paul does multiple different types of electronic engineering courses. You can find him on YouTube at Paul McWhorter or on his own website at www.toptechboy.com. Alright, enough talking about Paul. Let's get to the solution here. Paul had asked us to take our DHT11 and use a push button and convert over from Celsius to Fahrenheit. As you can see on the schematics here, we have a Raspberry Pi Pico W represented here. This is supposed to be a DHT11, but actually the white ones are DHT22s, but they're similar in the builds. There's a little bit different. I looked at the data sheet. There is a little bit difference, but for what we're trying to do, for the purpose of just seeing how it's laid out, that's just fine using a 22. Couldn't find 11 over here in my chart anyway. And then I have two buttons because I went above and beyond what Paul asked us to do. I actually included a second button to be able to do heat index. Celsius to Fahrenheit, Fahrenheit to Celsius conversion. And so then here on the board on this layout, the one on the left is B for our temperature. The one in this, the next one over closest to the temperature reading is actually used for heat index. Let's go out here for the layouts. We got ground coming down to the ground rail off of the Pico W. Then we have 3.3 volts going to the power rail, which is feeding to the power leg of the DHT11. Our next one that we got here is pin 28, GPIO pin 28, running down here to the data pin coming off. The next pin on the sensor is actually normally a closed pin, and we don't use it on this particular project. And then the next pin after that is our ground, going down to our ground rail. Over here to the buttons, we've seen the buttons before. We should know how it goes. One to the ground rail, the other one using for the data feeding through. And the Raspberry Pi Pico W has the internal resistor that will be able to pull it down. And then that's pretty much it right here. Let's go, for those of you who like to look at schematics also. Let's see why it's not pulling up here. And I'm pulling up everything else except for that. Sorry. Thought I had this laid out first. Apologize. Alright, this is a representation of our Pico W. This is a ground pin, or this is the GPIO pin indications. We're coming out with the GPIO pin 14 running to one of our switches, 15 to our heat index switch, connecting to the ground, which is physical pin 38. Then over here is our representation of our DHT11. This is actually the 11 one here. Ground coming off to the ground rail. 3.3 going into the VCC, and we're reading off GPIO 28, physical pin 34. Alright, let's look a little bit at what we did here for the coding. Imported machine and class pin, imported uTime with time. We can also import time and then bring in sleep if you want to do that, but uTime is actually specified through MicroPython. Time is actually through Python itself. So we'll go with uTime. We are using MicroPython. Let's do that. Then from DHT, import DHT11. So from the library DHT, we're importing DHT11, also from MicroPython. And then we're importing math because for me to do the heat index, I'm going to have to use the math functions. Okay, then we get the pins laid out here. We get the data pin of 28, which is coming off the DHT11. Then temperature button pin 14, 15 for the heat index. And then I had declared here to be able to do the push buttons. Temp button new, I got it set as 1. Temp button node set as 1. Is Celsius false? Is humidity Celsius false? Then heat index indication or HI button new 1, HI button old 1, and then I'm doing a delay of 1 second. Go down here and creating. We created our my DHT button. We did this just like Paul had did, using the function button, or sorry, pin, adding in our data pin. Then we're doing pin out, doing pin pull down. That's for the DHT11. We're doing a pull down on that internal pull down. Then we're running through the sensor through its function, and then adding in what we just created here to be able to do the math to figure it out. I'd like to do a more deep dive into figuring that out, but Paul just said do that and trust it, and it does it. Okay. And then next one is our temperature button, our object that I created there. Once again, pin, temperature button pin. It's a pin in and it's a pin pull up. I want that to be able to represent 1 when it's not being pushed. I know Brian and some other people had mentioned that they like to actually have it being pulled down. It just sounds more Boolean correct because we want it to be false and not true. As it's sitting here, it's sitting there going true instead of false because it's saying it's in your mind. You can think, wow, it's being pushed, but it's not. It's just being pulled up. Same thing with the heat index, and then I did some functions, like I said, for the math, converting over to Fahrenheit, converting over to Celsius, computing the heat index. To be able to compute heat index, it must be in Fahrenheit for the formula to be able to come out correctly. So that's why I went ahead and converted to Fahrenheit instead of just doing it down at the bottom. And we scroll on down here a bit more. This, I have got this from the National Weather Service. I had put it in the descriptions. You can see I give credit to those who dedicate their lives to learn math enough to be able to write these awesome, great big formulas. My hat tipped off to you. Great job. Someone has to do it. And then I'm returning here saying that if it is Fahrenheit, go ahead and return it into what we just figured it out. If it's Celsius, convert it over to Celsius. That's why we're running the Boolean of is Fahrenheit into as one of our arguments in here. We're bringing in temperature and our barometric pressure, relative humidity. Then we come down here and we do our while true loop. Excuse me, supper's trying to come up. Sorry about that. I did have a big challenge of trying to get my temperature and humidity sensor to work at first. I read a lot of what you guys had, or I read a lot, and then I also watched a lot of videos that other people had tried and what they'd done, because after not being able to get it going, I usually don't, well, I never watch the videos ahead, and this time is the first time I watched the video ahead, not to see how you guys did it, but to see how'd you get it to work. I couldn't get mine to read. And it comes to find out, embarrassing, I ran my wires wrong because my breakout board for my DHT11 switches over the data pin and the voltage pin. So it starts out data, then voltage, then ground. Compared to what Paul said, sure, the first one should be voltage, then data, then ground, and mine's not that way. Pulled out a lot of hair. Don't have very much hair to pull out, but I pulled out a lot of hair trying to figure out that problem. Okay, enough of that. Let's move on. Okay, then we do our sensor reading, which is also through that function that, of the object that we created, or through the object that we created. Now we're using that object as a function and calling in measure. Then I set a variable of temp seed to be able to read the temperature off that, and then did my temperature button new as the value for the push button, and then the same thing I did for the heat index or the value, be able to receive that value of knowing when I'm doing that. And then I did my first conversion here as a test, and I just went ahead and left it in there just to make sure everything was working in math wise. I did have to do some conversion because it was written for C++. Actually, it was written in a plain language. I wrote it for the rewrote it for the course that Paul does on Arduino, and actually contributed to that library on GitHub. So if anyone ever needs that HDT 11 library, I forgot who is the original author of that library, but I had added into it, he did not have the heat index conversion, and I went ahead and added that into the library. Maybe I can try to find that and put that in the descriptions if anyone's interested in the Arduino library. So after that, I had to convert it from C++ to Python. So I had to do some tests. That's where I did some tests to make sure my math was correct. And then I declared for the humidity. Once again, the same thing, doing tests. And in the heat index, we went ahead and used the function of that to convert it over. Then down here, I ran my if statements to be able to start doing the push buttons. And then pretty much I'm taking in that and making sure that the button that I pushed down is being pushed down, and it's already cycled through, so the old button is actually up 1 because we started out with 1. And then it looks and sees if Celsius, meaning if it's already been Celsius, then it does this conversion. If it's not Celsius, it'll go ahead and do the conversion this way. That would be, it'll be able to display the correct. Same thing down for the heat index. And then I shuffled the temp button so that the old now reads the new, and same thing for the heat index. And then when I did my interrupt, I just wanted to make sure it was done and put printed out stop. Alright, enough with that. Let's get and see what it actually looks like. And let me turn on that border camera. There it is. I got twisted. Okay, sorry about that. Let me try to reposition this. Alright, let's start this down here. I'm going to hit run, and it's waiting for us to be pushing a button. This button over here on this side right here will be for our temperature. It's reversed from what I showed you at the very first because it's facing towards me. My camera's on the opposite side. So if I push this button down, it says that we got the temperature of 25 degrees Celsius inside my office here. If I push it down again, now it says 77 degrees Fahrenheit. If I come over here to the heat index button, if I push that down, it says we have a heat index of 59 degrees Fahrenheit. If I push it down again, and it says we have 24.76 degrees Celsius. And this is show that it's flopping back and forth. I can push that down and push it again, and just kind of show that it's functioning correctly. And there we go. That 1 second delay, if you try to push it too fast, that 1 second delay, you might have caught it in between that 1 second delay. I read in a data sheet that it takes a minimum of 1 second. You cannot keep on pulsating it. It just won't work. Alright, so there we go. Nothing really too fancy. Just there, like Paul wanted, there's my solution. If you have any questions or comments, leave them down below. I'm open to criticism because that's the way how you learn. Someone gives you some feedback, you take it, you either grow from it or you let it go bye-bye. If it bothers you, it shouldn't. You just want to learn from it. And let's see here. Yep, I believe that's all of it. Until next time, be safe out there, everyone.